everyone. In today's video, we are going to cover rotations. Our learning targets for today are I can identify a rotation and I can find the coordinates of a figure rotated about the origin. Now, rotations about the origin, we call rotations turns around a fixed point called the center of rotation. Now, our figure rotates a specific angle and direction. The most common angles that we will rotate are around 90 degrees, 180 degrees, and 270 degrees. The most common direction that we will move is counterclockwise. If you are not specifically told what direction to rotate, you should rotate counterclockwise. Now, we will also rotate our figure around many certain points. However, the most common certain point that we will rotate around is the origin. Now, for 90, 180, and 270 degree rotations, we have rules for rotating around the origin. For 90 degree counterclockwise, we would have the coordinates x, y. Our rule would change the coordinates x, y to opposite y, comma, x. For 180 degrees, our coordinates x, y would change to opposite x, opposite y. And then 270 degrees, our coordinates x, y would change to y, opposite x. It will be very helpful to remember these rules to make our 90, 180, and 270 degree rotations. Now looking at our example 1, we have triangle ABC with the following vertices. I want to make a 90 degree counterclockwise rotation. So again, rotations are turns. Each 90 degree that we rotate is one turn around the origin. So if I want to make a 90 degree counterclockwise rotation, that's one turn into quadrant 2. If I was making 180 degrees, I would rotate it one more turn, and 270 would be one more turn. So 90 is one turn, 180 is two turns, 270 is three turns. Now, if I want to make a 90 degree rotation, I can simply apply my rule, which was opposite y, comma, x. So I will flip the x, y positions and then make the original y coordinate the opposite. So a prime was 2, 7. My 7 will become negative, so negative 7, and it will be in the x position. So a prime would be negative 7, too. B prime, 6 and 5 would flip to 5, 6, and then my y original coordinate of 5 would switch to negative. So B prime would be negative 5, 6. And then C prime, again, I would switch my 1 and 4 and then make the 1 negative, so I'd have negative 1, 4. Now, another way that I can think about this is visualization. So if I'm going from quadrant 1 to quadrant 2, I know quadrant 1 are positive values and quadrant 2 are negative positive values. Now, knowing for 90 degree rotations and 270 degree rotations, my x and y coordinates switch, I can always switch those coordinates and then visualize what value should be positive or negative. So if I'm going from quadrant 1 to quadrant 2, notice my x coordinates are all negative, which in my 3 prime coordinates, all the x coordinates are, in fact, negative. So if I want to remember for 90 and 270, I switch my coordinates, and then based off of what quadrant it goes into, change the values of my signs. That's another helpful way to think about making rotations. So now if I plot negative 7, 2, negative 5, 6, and negative 1, 4, it would look like this. So we have now triangle A prime, B prime, C prime after a 90 degree counterclockwise rotation. Now looking at number 2, I have square PQRS with the following vertices. I want to make a 180 degree rotation. Now notice 180 degree doesn't have counterclockwise or clockwise because 180 degree clockwise is the same as 180 degree counterclockwise. Now, if I want to make a rotation of 180 degrees, I can remember my rule. I know that opposite x, opposite y would be my coordinates after a 180 degree rotation. Or if I'm more of a visual person, if I take my coordinate plane and simply turn it twice, so that's one time, that's two times, this would be my figure after a 180 degree rotation. So if you want to physically take your paper and rotate your paper in the air, that also is a rotation around the origin. So again, one turn would be 90 degrees, two turns would be 180 degrees, and three turns would be 270 degrees. Now with this, I can simply identify what my values of the coordinates are, and then I can rotate my figure back to its original position and then plot those points. So notice P prime would be negative 2, negative 6. Q prime would be negative 6, negative 5. R prime would be negative 5, negative 1. And S prime would be negative 1, negative 2. So if I write these coordinates on the side of my original figure, now I can rotate back to my original position, which it was in quadrant 1, and I can simply plot my 4 coordinates. And then triangle P prime, Q prime, R prime, S prime would look like this. So if I want to make a 180 degree or a 90 degree or a 270 degree rotation, I can also turn my paper instead of just applying my rule. Now looking at problem 3, I have trapezoid JKLM with the following vertices. I want to make a 270-degree counterclockwise rotation. So again, I could either utilize my rule or I could physically rotate my paper 3 turns. So if I rotate my paper 3 turns, this is what it should look like. I could write those coordinates down. Or if I apply my rule for 270-degree counterclockwise rotation was Y opposite x. So my x and y will switch, and then the original x coordinate will change to be the opposite value. So if I make a 270-degree counterclockwise rotation, j prime would go to 4, -3, k prime would go to 4, -6, l prime would go to 1, -8, and m prime would go to 1, -1. Now drawing in trapezoid J prime, K prime, L prime, M prime, that would look like this after a 270-degree counterclockwise rotation. Now looking at this example, I have triangle LMN with the following vertices, and I want to make a 90-degree clockwise rotation. So my rules that I have apply to counterclockwise rotations. So if I want to make a clockwise rotation, I need to find out how many counterclockwise rotations a clockwise rotation would be. So if I have a 90-degree clockwise rotation, that's 1 turn to the right, which would also be 3 turns to the left, which would be 270 degrees counterclockwise. So a 90-degree clockwise rotation is the same as 270-degree counterclockwise. 180 would be the same for both clockwise and counterclockwise. And then if I had a 270 clockwise rotation, that's a 90-degree counterclockwise rotation. So applying my rule for 270-degree counterclockwise rotation, I would have y opposite x. So my coordinates would flip, and then the x value, the original x value, would change to be the opposite. So notice I have 1, 5 as L, so they would switch, and then my 1 would become the opposite, so I'd have 5, -1. M would be 8, -3, and N would be 1, -8. Now drawing in these new coordinates, I would have the following triangle, L prime, M prime, N prime, after a 90-degree clockwise rotation. In this lesson, we learned a rotation is a turn around a fixed point. We have 3 rules for 90, 180, and 270-degree counterclockwise rotations. 90 counterclockwise, our xy coordinates change to opposite yx. 180-degree is opposite x, opposite y, and 270-degree is y, opposite x. That's a wrap on this video. We'll see you in the next one.